Okay, first law of motion. So now this is our second video here of this little subset. And when we look at the first law of motion, I picked this nice little picture. And this is one of those ones that is taken with like kind of a slow motion camera. And you can kind of see that the impact of the punch is working on the guy's face, but you see how his nose is kind of bent back like this. The reason why, of course, is the tip of his nose had this property that we call inertia. So in other words, it wanted to stay in place, okay, when his face started to go like this. And inertia then is really one of those things that we talk about in terms of it's the resistance of wanting to change its motion, or an object want to change its motion. So you may remember then we had our kind of basic 9th grade definition of what the first law of motion was, which was an object at rest stays at rest and an object in motion stays in motion. Now, this is where, Newton kind of evolved this into, he said, motion just means that we're moving, but we're moving with a constant velocity. Okay, and so that's kind of an important feature. So either we're sitting, resting, okay, no motion, or we have constant motion, which we actually refer to constant velocity. We're not accelerating motion, okay? And so that was the difference in how he kind of wrote this up. Now, ultimately, he's saying that we have this property of matter that we call inertia, okay? And you may remember from our Bill Nye videos that inertia is a property of matter. So that was part of that whole theme song. But really, it was down to the point to where he said all the forces that are acting on that object are balanced, okay? And when we say balanced, I may also use that we're at equilibrium, okay? So equilibrium is equal to that word balanced, okay? So if I have a force that's acting up, I also have a force that's acting down, and the two forces kind of cancel each other out. That's our kind of thing that we're going to talk about. Interesting, when we start to use forces, we like to use forces in terms of arrows, because forces are vectors, okay? Forces are vectors, and so if I have an arrow that's going up and an arrow that's going down, they kind of cancel each other out. So it works the exact same way that we've been using arrows so far in other topic sets. And then if we have a force that's acting this way and we have a force that's acting this way, the two forces result in a force that's acting that way. So we'll see that triangle relationship that's going to tie in on this too. The forces are nothing more than arrows, okay? They're vectors. And in this case, all of them are balanced, or they're in equilibrium. So in other words, all of my forces, my up arrows cancel my down arrows, my left arrows cancel my right arrows, and that's how we kind of look at this being balanced. So there you go. That's the first law of motion. And I'm going to just kind of set up so that we'll be talking second law of motion next.